Let's take a look at light waves and electrons. I want to remind you that our goal is to be able to express the arrangement of electrons in atoms using electron configurations, as well as being able to draw the Lewis valence electron dot structures. And right now, my goal is to show you how we get information about where the electrons are so we can write electron configurations. So, I want to introduce you to photo emission spectroscopy, or PES for short. This is the study of the light that's needed to remove electrons from an atom. We talked about how light can be used to make the electrons move inside an atom. Here, I'm actually going to use light with high enough energy, a high enough frequency to actually remove the electron. And what I get is a graph that looks something like this one. This is the PES for hydrogen. And on the x axis, we get the energy needed to remove the electron. And notice that it actually starts with 0 on the right and it gets bigger going to the left. This is opposite of what we normally see. But this tells me relative to the nucleus how far away I am. And the peak height is going to tell me how many electrons are there. So here is helium and hydrogen. And the first thing I want you to notice is that the helium peak is twice as big. And that's because hydrogen only has one electron. Helium has two electrons. Its atomic number is 2. And we also notice that the peak moves over to the left a little bit. And that's because it takes more energy to remove the electrons from helium than hydrogen. And what this tells me is that the electrons for helium are closer to the nucleus. And that's because helium's nucleus has more positive charges. Now, as I look at more elements, I start to see more about where the electrons are. So let's look at lithium. Lithium is going to be in blue, and lithium has 3 electrons. Helium is still in pink, and it has 2 electrons. So we only see one peak for helium, and that's the pink one. But lithium, we actually see 2 peaks. And it turns out that not all of the electrons are in the same area around the nucleus. And we have a word for the areas where we can find electrons, and that is energy levels. And so lithium actually uses 2 different energy levels to hold its electrons. The first energy level can hold 2 electrons, and the next one has to hold the third one. And we see a big jump. There's a lot of space between these 2 peaks, and that's my evidence for an energy level when there's a big space. And you might remember from 8th grade chemistry hearing something like energy levels can hold a certain number of electrons. The first energy level can only hold 2 electrons. This is that evidence, 2 electrons, and then the third electron has to go into a new energy level. Now, if we look at atoms with even more electrons, here's sodium. We start seeing that even within energy levels, there are multiple peaks. And we call these sublevels, more defined areas within an energy level. So here in this spectrum, you can see 3 energy levels where I'm separating them with a dotted line to show you that this is kind of the big jump. So this is the first energy level. This is the second energy level. And then here's our third. And in our first energy level, we have 2 electrons, 1, 2. In our second energy level, we have 1, 2 in the first sublevel, and then 3, 4, 5, 6, 7, 8 in that second sublevel. And again, you might remember 2, 8, 8. Now we're going to find that it's not quite that simple, but this is the evidence that we see for energy levels and then sublevels. And now we're going to start labeling these so we can start communicating where these electrons are.